Okay, we've got number 1, determine whether the equation defines y as a function of x. This pesky y squared is the issue, because if we remember, one definition of a function is that it passes the vertical line test. We could try to graph this on our calculator, but to do that we need y equals. And so if we start to try to solve for y, hopefully when we do this we remember that, hey, when you square root you gotta put a plus or minus. And if you graph that, that will, because you have to graph both parts, it'll be a parabola lying on its side. If you look at the vertical line test, that does not pass. So we'd say, no, this is not a function. That y squared, I mean, that's one of the only ways really that we don't get a function at this point is at pesky y squared. Graph the function on your calculator in order to answer the following questions on number 2. If you do graph it, you should see that up here at 4, at 0 we're at 4, and then we've got this curve going down. And depending on your calculator window, it may look like it's approaching 0, maybe a horizontal asymptote thing. But if you think about it, this is a square root function, so it shouldn't have an asymptote. And in fact, it will actually just continue to keep going down indefinitely, although it does go at a pretty slow pace pretty quickly. But you can look at your table of values to help you see that as well. So we've got some questions here. On what intervals are we increasing or decreasing? Well, we look at our x values from left to right. It looks to me like we start doing anything for our graph at 0. And we don't actually increase at all. We just decrease from 0 to infinity. And so you can either put a parentheses around 0, or you could put a bracket around 0, since our function is defined at 0, whichever way. I like to put parentheses personally because I like to play it safe, but whatever. Hazelwood disagrees. Okay, odd means symmetric about the origin. Even means symmetric about the y-axis. This is not symmetric about the y-axis, or we'd have a little thing going this way with some symmetry. It's not symmetric about the origin, or, oh, this is a tough thought. How do I get this to be down here, like something like that? I don't even know. Like, that's hard to imagine. It'd have to be something, though, in the third quadrant, and that's not happening. So it's neither even nor odd. Extrema, for our definition, we are talking about where does it switch from increasing to decreasing, and since it doesn't switch from increasing to decreasing, there are no extrema. Horizontal asymptotes. No horizontal asymptotes, because that typically is going to happen for us whenever we have a fraction and we are looking for where we have a 0 on the bottom of that fraction. Okay, like we said, you may think at first, oh, this has a horizontal asymptote, but if you look at like the table of values, your y values will get more and more negative. They do slow down, but it's not in such a way that it's like, oh, it's approaching this number. How does this graph relate to the graph of one of the 12 basic functions? Well, it's relating to the square root function. That's its parent, because, hey, look, there's a square root. And what they have to do, this is actually kind of tricky because the order does matter here. They had to have reflected across the x-axis, y-axis, x-axis, no axis. No, seriously, x-axis. They reflected across the x-axis, and then they shifted up 4. Sorry about my moment of indecision there, but a normal square root function looks like this. Well, if we just move it up 4 and to here, and then tried to flip it, that'd be down here. Well, that's not what we had happen. So they had to flip it first. They had to take this function and flip it, and then they moved it up 4. So we shouldn't have something quite that tricky on our semester test. How to tell algebraically if something is even, odd, or neither. You plug in a negative x, and you look and see what happens. If everywhere there's x, you put in a negative x instead. We're basically trying to see if these negatives would go away for some reason. And what kind of reasons would that be? Well, if you square a negative, it goes away. Okay, so it would leave this term, basically, it'd leave that alone. Also, an absolute value of a negative makes that negative go away. And then 8 doesn't have an x, it stays the same. Because all of our signs here remained the same, this is an even function. If all the signs change, if all of them change, that's when it's odd. If you've got some mixture of the two, some of them change, some of them don't, that's whenever it's neither, if you're doing this algebraically. We want to graph this piecewise defined function. So for the left half of our graph, where x is less than 0, we want to draw the absolute value of x plus 4. You can do that on your calculator. It starts at 4 here, which we would really want an open dot there, even though I just closed it in. And then it's a v going this direction. Okay, and then where it's greater than or equal to 4, that's a horizontal line at y equals 4. And since it meets up, we don't have to worry about the fact that the first one at 0 should have had an open dot. They should match up here. Okay, so that's our answer for that piecewise defined function. Requested operations, f of g of x means take g, plug it into f. So take g, put it where the x is in f. So 8 times 3x minus 1 plus 14. So we distribute and add like terms. So 24x plus 6 is what f of g of x equals. Find functions f of g so that you can, basically this is telling us to break this up so that if we were so inclined, we could take whatever we pick for g and we could plug it into f and we could get this. So what I'm plugging, you basically are splitting this up into two things. What I'm plugging into has to be this fraction. I have to plug into something like 1 over x. And then if that's what I'm picking to plug into, then what I need to plug in is x squared minus 3. Now think about it. If I take x squared minus 3 and I put it in here where x is, I get what I started with. So we gotta think kind of differently for that. Inverse of the function. This is really like y. You switch the x and the y. You solve for y. So x minus 6 equals y cubed. Cube root each side. Now you may ask yourself, because you can't ask me because I'm not there, you may be like, hey, do I need one of those plus or minuses? And you should say back to yourself, no, I don't, because this is an odd root. Even roots you need plus or minus, odd roots you do not. So there's that. This is a good page. This one has a lot of stuff here, so let's just dive in. 1-to-1 means it passes the vertical and horizontal line test. Oh no, it does not pass the horizontal line test, so it's not 1-to-1, which is one way of writing it, is 1-1. So now you've learned something even more new. The graph of f of x equals the cube root of x is shifted 7.6 units to the left. So that's inside here. Left means opposite, so that's plus 7.6. It is then vertically stretched by 4.7, so that's times 4.7 on the outside. Reflected across the x-axis means I don't make x negative. That would be too easy. I have to make the outside negative. Bam. 10. Gotta remember how to set this up. 10% of, we don't know, we're finding how many liters, plus 0.5 times 60. Okay, we're adding these two solutions together. It's 0.1 of something plus 0.5 times 60. But we know that we want to end up with 0.2 of, well, how much do we get if we add x and 60 together? We get x plus 60. Now we solve this. So 0.5 times 60 is 30. 0.2 we distribute. I'm kind of hoping that's 12. 0.2 times 60, 120, that's 12. Get stuff on the same side as the other stuff. So X is 180 liters. Sue invested $10,000. Part at 3.8%, so that's 0.038. And we're going to say that's X plus 0.07. Well, if we invest part is X and the total is 10,000, then this one is 10,000 minus X equals our interest, which is 603.68. And then we solve that. So 7,000. And add like terms. So negative 0.032 X. Subtract the 7,000 over. I probably should have anticipated a calculator situation. Or had my review with me, but it's like taped to my board. So, okay. Negative 6396.32 divided by negative 0.032. Something has gone terribly wrong. Like the fact that this is 700. So 603.68 minus 700 is negative 96.32. And divide that by negative 0.032. That's 3010, and that's how much X is. So X is the investment at 3.8%. 10,000 minus 3010 will tell us what Y, well, there is no Y here, but just 6990 would be our amount at 7%. Keep going. We've got this linear function. So this is x1, y1, x2, y2. We've got slope. We've got point slope. And so that means that we would have 4 minus 8 over 1 minus a negative 3. So that's really plus 3 minus 4 over 4, negative 1. So we pick either point. So y minus 8 equals negative 1 times x plus 3. Or you could use the other point. Also, you could solve by distributing and then adding 8. But make sure you distribute first. And you should get y equals negative x plus 5. In case it's multiple choice, never know, be a good idea to do that. So we take for the vertex the opposite of what's inside the parentheses, which is would be a negative 5, and we take the outside as is. The axis of symmetry is simply x equals the x coordinate from here. Write an equation for the quadratic function whose graph contains the given vertex. So there's a formula there for that standard form situation. And so we know h and k and an x and a y, so we can plug in and find a. So we just gotta be good algebraic solvers. A equals 3, and then you write it 3 times x minus 1 squared. Just kidding, minus 3. So that's what h is, plus 1. And you may want to practice FOILing that out. X minus 3 times x minus 3, multiply by 3, add 1, just in case, multiple choice kind of situation. Let's analyze. So there's all kinds of stuff that we do when we analyze. We do domain, range, continuity, symmetry, increasing, etc. Extrema, asymptotes, in behavior and boundedness. And I will have these listed for you so that you don't have to know them. Well, if we graph this, you should end up with something that basically looks like this. It looks a little bit different on your graph, but the important thing to realize is that we do have an asymptote going this way and an asymptote going this way. And if we think about this as being 4 over x to the third, it should be kind of obvious-ish, at least, that there's a vertical asymptote at 0. Maybe the other one's not so obvious. Oh, it asks us for the power, which is -3, the constant of variation, which is 4. The domain is, skip the 0, everything but 0. The range is also everything but 0. It is not continuous, and its discontinuities happen at x equals 0. So I didn't mean to make that plural. It's symmetric about the origin, because you can take what's up here and rotate it around and it's down there. It's actually not increasing at all, it's decreasing the whole time. And because it's decreasing the whole time, there's no extrema. We said there were asymptotes, a vertical one at x equals 0, a horizontal one at y equals 0. It is not bounded, because we can get to positive infinity for y and we can get to negative infinity for y. The end behavior, the limit as x approaches negative infinity of f of x. Well, as I go farther and farther to the left for x, I'm getting closer and closer to 0. And as I approach positive infinity, I'm also going towards 0, because now I'm going this way, getting closer and closer to 0. So that's that right there.